Hi there, folks. This video is going to be a complete review, and it should help you complete your weekly skill set. In this video, we're going to review solving systems of linear equations. And recall that when you solve a system of linear equations or inequalities, because we'll be doing both, what we're looking for is a set of points that satisfy both equations at the same time. Okay? So graphically, that's the point of intersection of the two lines if they're equations. Or, if they are inequalities, it's the overlapping region, because remember, when you graph an inequality, you're looking for shading. Okay? So you're going to be shading this. So, now, first of all, let's remember a little bit how to graph, because I know for some people it has been some time. Okay, remember, slope-intercept form. If m equals the slope, so rise over run if it's written as a fraction, b is the y-intercept. Okay, and that's what we're going to use as our starting points. Okay, so here I have two equations. And the first one is y equals negative x plus 8. The other is y equals 4x plus 7. Now, since these are not fractions to begin with for slope, I'm just going to make them both fractions by putting them over 1. Now, since technically there is no number here, okay, it is implied that that is 1. So I could put that over 1 as well. So I'm going to graph the first equation. So I'm going to go up 8. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put a dot there. Now, I'm going to go, because it's negative 1, I'm going to go down 1, and then I'm going to go right 1. So there's the next point on the line. And I could do that again. Down 1, right 1. Okay. Down 1, right 1. Now, these don't exactly make a perfectly straight line. Okay, but that's because I've kind of messed up a little bit on my markings, but that's okay. You can avoid that by using graph paper. So anyways, I'm going to connect these points here. So there's that first line. Now, I'm going to use a different color for the second line. So, that's blue. This is going to be red. Not real sure how well that's going to show up, but that's the intent. So, for this next one, I'm going to start by going up 7. I'm sorry. That should be minus 7. Okay? So, I'm just going to make this plus negative 7. Okay. So that's my error when I wrote the equation. So I'm going to start by going down 7. So 1, 2, 3, 4, 5, 6, 7. Place my first point. Now, to get my next point, I'm going to go up 4. 1, 2, 3, 4, right 1. I'm going to do it again. 1, 2, 3, 4, right 1. And do it yet again. Okay. Well, anyways, 3 points should be good enough. I'm just going to connect these. And now, what I'm looking for is, where do these two lines intersect? Okay? And it appears that these intersect at the point 3, 1, 2, 3, 4, 5. Okay? So it appears that they converge or intersect at the point 3, 5. Now, I'm just going to confirm this, okay, by plugging them into both. By plugging this value in for x, this value in for y, and see if that's true. Okay, I believe it to be the case. So, does 5 equal negative 3 plus 8? And in this case, yes, it does. So it checks out for the first one. For the second one, does 5 equal 4 times 3 minus 7. Because like I said again, that should have been minus 7. That was my error. So 4 times 3 is 12. 12 minus 7 is 5. So that checks out, which means that 3, 5 is a solution. Or the solution in this case, because they only can cross one time. So that's how you solve a system of equations. Now, if it's an inequality, system of inequalities, it's a little bit different. Okay? In this problem, I have x is greater than or equal to 2, and negative 5x plus 2y is less than 8. Now, recall that with inequalities, if the line is underneath the equal sign, is underneath the greater than or less than sign, when you graph this, it's a solid line. However, if it does not have equal to, you will make a dashed line. So I'm going to graph this first one. Now, because it's just x, that means it's going to intersect the x-axis at 2. All right? So it's going to intersect right here. And because there is no y variable, it's just going to go up and down. Now, because it has the equal sign to it, that means it's going to be solid. So I'm going to draw that in right now. Okay. Now, because it is greater than, okay, the numbers where x is greater than are to the right. So I'm going to shade these to the right. Okay. I use big, wide lines for my shading. It just makes things a little bit easier, especially for demonstration purposes. For the second inequality, it's not in slope-intercept form. So I'm going to get it that way. So I'm going to add 5x to both sides. Okay, so 5x plus 8. Okay, I know it's plus because that's a positive 8. Then I'm going to divide everything by 2. So this is really what I'm graphing. Now, remember, if I had divided by a negative number, I would have had to reverse the sign. So let's see what we get. Again, I'm going to use red for this. So I'm going to start off by going up 4. Let's see here. 1, 2, 3, 4. Placing a dot. And then I'm going to rise 5 and run 2. 1, 2, 3. Looks like I need a few more places here on my graph. 4, 5. Then I'm going to run 2. Okay, I'm going to extend this just a little bit. Okay. So 1, 2, 3, 4, 5. And then run 2. 1, 2. Now, because this is a less than sign, and it doesn't have the equal to with it, I'm going to draw a dashed line. Okay, that's not showing up that well, so I'm going to make those a little bit darker. There we go. Now we can see those. Now, for how I choose to shade this, okay, it says y is less than 5/2 x. Okay, well, since I should test a point, so if I put 0, 0 in, if that point is true, I would shade this side of the line. If that point is false, I would shade the opposite side. So 0 is less than 5/2 times 0 plus 4. And 0 is indeed less than 4. So I'm going to shade where 0, 0 is. So that's to the right. The other trick is if y is by itself and on the left, if this is less than, you will shade below the line, okay, where it intersects the y-axis. So in this case, it's going to be to the right. Now, I'm going to again use these long lines and the solution to this set of inequalities is this region where the shading overlaps. Okay. And that is our tutorial on how to solve systems of linear equations or linear inequalities using graphing. Okay. Have a good night.